In this video, I want to look at a little bit messier function and a little bit more complicated intervals. So one thing I notice is that my function is rational, so it is discontinuous at x equals 3. So I'll have to check carefully around that discontinuity to make sure that I don't lose the possibility of even having a global max or min if there's asymptotic behavior. And then the other thing that's a little tricky here is this first interval does have an open endpoint or an open-ended endpoint, however you want to say that. So I'll have to investigate that carefully. Okay, so going through the steps for this first one, I will need to find my critical values. So I'm going to go g prime of x, and let's use a quotient rule. So we need the bottom times the derivative of the top minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. And I can simplify that a little bit. I get a 2x squared minus 6x minus x squared over x minus 3 squared, which ends up being an x squared minus 6x over x minus 3 squared. Okay, and I want to know when is that undefined, and the answer is at x equals 3, but that's not a critical value because we've already classified that as a discontinuity. So that's kind of a, we don't list it there, but it is important. So if you hadn't already noticed it, you would want to mark down for yourself that that's a discontinuity. We also want to know when is the derivative equal to 0. And in solving that algebraically, my first step would be to clear that denominator, or logically you can think through and say the only way to make a fraction 0 is to make the top 0. So I need to know when x squared minus 6x is equal to 0, which means I can factor x times x minus 6 equals 0. So x has to equal 0 or 6. The only one of those that's in the interval that I've got for this part is x equals 0. So I think I'm ready to start making my list. I need to check the y value at any closed endpoint or critical value. So I will want to check the y value at 0, and I will want to check the y value at 2. I also need to check, but this is for is there really a max or a min, not for is this the max or min. I need to check out what's happening as x approaches negative infinity. And if it was in my interval, I'd also investigate what's happening near x equals 3, but that's not in my interval. So x equals 3, not in interval. So we can ignore it this time. So this is my full list. When I plug in 0 for x, I get 0. And when I plug in x equals 2, I get 4 over negative 1. I get negative 4. Once again, remember, this is in the function, not in the derivative. So these are my y's. I then need to think about this limit as x goes to negative infinity. You generally aren't going to need to do a bunch of algebraic messy derivative work for these. If that comes up, go for it. But usually you could just kind of think through the behavior of the function. And I actually think that's a really important skill in general anyway. So try to do it that way. If in doubt at all, go ahead and use a calculator to plug in some values and check yourself. So in this case, x approaching negative infinity, I'd maybe want to plug in negative 1,000,000 and then negative 1,000,000,000 and see what's happening to this fraction. But in terms of just thinking through it, if I plug in a big negative number, the negative 3, the minus 3 in the bottom, is going to become negligible. It's not really going to make a difference, hardly at all, in the value of this fraction. So we're basically looking at a really big negative number squared over that really big negative number. So I notice that it's positive over negative, so it's going to be a negative answer. And the top is way bigger than the bottom, right? We have x squared over x, so the top wins there, which means this should head to negative infinity. Again, if you don't feel confident in your reasoning through that, plug in some numbers and check yourself. But that's what I see happening here. And this means that I will have no global minimum. So we will have a DNE for global minimum. The global maximum is going to be at x equals 0, and the maximum is 0. So that's the global max. So a maximum of y equals 0 at x equals 0. All right, let's investigate what happens on the interval 0, 6. This is now a closed interval, so I'm feeling a little more optimistic that I'll get a global max and a global min, but my discontinuity now falls in this interval, so it's still questionable. So this time I need to check f of 0 and I need to check f of 6. Interestingly, those were my critical values as well, so I don't have to add anything to the list for critical values. But I do need to investigate this. Am I confident that there really is a global max or min? So I'll need to take the limit as x approaches 3 of f of x. Oh, I said f of x a whole lot of times. Here's what we're going to do. I just realized that my function is named g. I'm going to call it f now. Way late, but I think you'll get the idea. F of 0, we already figured out, is 0. F of 6 is 36 over 3, which is 12. So just based on that, I would say now my minimum is at 0 and my maximum is at 12. But I need to investigate this asymptote at x equals 3. And we'll need to do this carefully. When you think you have an asymptote, sometimes you need to split it up and look at both sides, because one side could go to infinity and one side could go to negative infinity, or they could both do the same thing. And that's going to make a difference in whether I think I have a global max and a global min. So if I plug in numbers, let me rewrite the function. F of x equals x squared over x minus 3. And again, this is challenging just thinking through this. Check yourself with your calculator, that's great, but try to think through it. So I want to imagine plugging in numbers slightly bigger than 3 first, so like 3.1, and then you could do 3.01, 3.001, but this should give us the idea. The top is a little bit bigger than 9. The bottom is a tiny, tiny positive number, depending on how close to 3 I get. We are getting a positive divided by positive, so the answer will be positive. And dividing by smaller and smaller and smaller numbers make your answer bigger and bigger and bigger. So I think this is going to go to infinity. When I plug in something very slightly smaller than 3, so something like 2.9, the top is still getting really close to 9. It's now just shy of 9. The bottom is now a very small negative number, and the closer to 3 you get, the smaller that negative number will be in the bottom. Dividing by tiny, tiny numbers makes big numbers, but now it's a positive divided by a negative, so I'm getting negative infinity. So this is one of those asymptotes where, let's see which side. The left was going down to negative infinity, the right was going up to positive infinity. There is no max or min. This has no global max or min because there's an asymptote shooting off in both directions. So make sure you investigate carefully next to those discontinuities. Check on both sides. All right, thanks for watching.